Alright, hi everyone, welcome to my YouTube channel, City of Electrons. And in this video we are going to work an example, okay, which is calculate the projection of a general vector A onto another general vector B. Now this is kind of the key word here, projection. Okay, so from our last video we talked about the properties of a scalar product, and we mentioned that this property here, that the dot product can be seen as the magnitude of vector A multiplied by the magnitude of the projection of vector B on A, okay, or vice versa, that's vector A on B. So the idea here is this: what do we even mean by projection? So I'm going to explain that, but let me just add this. Okay, so last video we talked about properties of scalar product. This is also part of it. That is, the magnitude of a dot product is always less than or equal to the product of the magnitude of vector A and vector B. Okay, so that's just an addition to last video. Now, so for this video I want to work this example, but first I'm going to explain what we truly mean by projection. So when we see, so of course this is for vector A and this for vector B. Okay, so when we see general vector, when we see and this is a general vector, so when we see projection, now look at this. Imagine we have this, we have something like this. Okay, so if we have this, and let's say this is oh boy, come on. Okay, now let's say we have this, okay, and then we'll have this way. So this is vector B and this is vector A. Let's put it there, A, and then B. Okay, so this vector A, this vector B. What we mean by the projection of, look at it, the projection of a general vector A onto another B, projection of A to B. This is what we mean. Now imagine you shine a light, okay, like this. Okay, if you shine a light like this, it will cast a shadow. It will cast a shadow like this, downwards. Okay, so cast a shadow downwards. So the shadow of, let me just say, the shadow of vector A that falls on B, so this part is the projection of A on B. Okay, so just, of course, all these other parts, they are not, doesn't form a shadow of vector A, but this part here at this point forms a shadow of vector A onto vector B. Okay, so from this point here to this point, that is the projection of A on B. We can see that it's on top of B. Okay, so this is the projection of A on B. Now obviously its direction is the same as the direction of B, but what is its magnitude? You know, when we say a vector, we need two things: magnitude and direction. Okay, we need magnitude and direction. So for this guy now, we need its magnitude and we need its direction, but of course we are seeing its direction already. So we can solve for magnitude first, but let me just put down the direction since the direction is so obvious. So for direction, let's say A onto B. Okay, so for the direction, it is the same. It is the same as the direction of B. The same as B, and same as B. And we know that B, or the unit vector for B, is the value B divided by its magnitude. Okay, so we said this in previous videos. So since the projection of vector A on B is in the same direction with B, so you can see the direction of vector A on B, that's the direction of the that's the direction of the projection of A on B is in the same direction with B. That's obvious here now. That's obvious. It's in the same direction with B. That means the unit vector of A and of this and this will be the same. And recall that the unit vector is the vector divided by its magnitude. Okay? So we are done with the direction. So this is for direction. Bring this down. Okay, so for the direction of the projection of vector A onto B, that's for the direction. Then for the magnitude, good. If magnitude, remember we said magnitude is just the size or length. So for the magnitude of projection of A onto B, let me come closer. So for the magnitude of projection of A onto B, that is magnitude, what is this length, this distance from here to here? Note that there is an angle here. This is theta, and this angle is the angle between A and B. Angle between A and B. So to know this guy, this length A and B, we are talking about this, and we have something here. That means we can use cosine, because this is the angle, this adjacent, this hypotenuse. That is just idea of course. That means we can say cosine the adjacent, which is this now, AB. So adjacent AB, that's A onto B. Then the hypotenuse here is this magnitude of A. So no, our cosine should be, there should be an angle here. Excuse me, let me take that back. So yes, there's an angle here. This is cosine of the angle A and B, angle between A and B. So this for the magnitude of A onto B. Okay, so if you cross, let me just put this modular sign. So when you of course multiply at this point, this goes this way like that. When you do that, you will have the magnitude of A onto B as A cos theta. I'm using theta here instead of 5, whichever one you use, theta or 5, whichever one is the same thing. Okay, so let's use that for uniformity. Let's use that. Okay, so we get the point. So when we see the magnitude of A onto B, it's just this. Okay, this onto this. Alright, so you can use this method to get the magnitude, and then you just bring the unit vector together with it, which we already have as the same direction of B. So you can use this to get this approach to get the magnitude, or you go back to the formula, which the formula of dot product, and you still get the same results, the same magnitude. Saying that remember we have a formula that says A dot B is the same thing as A B, that's the magnitude of A, the magnitude of B, cos what? Cos phi A B. Good. So what we can do now, this is, of course, this is a formula from previous video. Okay, so what we can do now is just to take this point and say, look at, let me use this, just to take this point. Okay, yeah, because this is the this part here is the projection of A onto B. Look at this from the previous video. Okay, where are you? Okay, here it is. Okay, so this part B cos phi AB is the projection of B. That's the magnitude. Okay, this is the magnitude of the projection of B on A, while this is the magnitude of the projection of A on B. Okay, so that means we are going to take this guy this way, so that's divide both sides by this, of course, by B, so that we have this and this at one side, because this, let's just write that, because this cos AB is regarded as the magnitude of the projection of A onto B. So of course this will now be A B, and being that we divide, this guy will come down here. Okay, and that will be this. Okay, so this is the magnitude of the projection of A onto B. Then for the direction of A onto B, we already have it. We already said it's going in the same direction, and this is it. So all we have to do is just to compute the values, or compute what we have. So we call this equation 1, and then call this, I think we should switch this even, as we should have this guy this way, and then have this guy this way. I knew it. Okay, makes more sense. Alright, so now all we have to do is say the projection, so that means we now have the magnitude. So equation 1, let's say equation 2. So equation 1 is the direction. Equation 1 is the direction of the projection of A onto B, while equation 2 is the magnitude. And of course a vector has magnitude and direction. So we just have to join equation 1 and 2. That is, to get the vector projection of A onto B, we need its magnitude, we need its direction, of course, which is same as B, and then its magnitude, which is B dot A over B. Okay, so this is it. Okay, this is it. But just to expand, so it will match with what you have in class, just to expand it, or should I even expand equation 2? Let me take this down first. Let me cut out this guy. So I'll bring this guy back. Okay, let me just cut it. Then I will expand equation 2. So equation 2 can also be written as A dot B, written in its explicit form, like we said in the last video, is AX BX plus AY BY plus A. See, we said this in the last video. Okay, so you can check that out. And of course all over BX squared plus B squared Y plus B squared C. Okay, so yeah, this is exactly what we have in class, and of course we have this for the magnitude. Okay, cos 5ab. Good. So you can call this equation 3 if you want. Call this equation 3. So now let's merge equation 2, equation 1 and equation 3. That's just like saying let's merge the unit, that is the direction, and then the magnitude. Direction and magnitude together is a vector, and the vector we are talking about is this one here. This one here. Let's just call this A onto B. Hallelujah. Okay, so of course we have written that out before, so I'll just paste it here. Good. So now what is this? This is equation 1 now, and this is equation 2. So we just put in what they mean. So A onto B is same thing as, for that's for the unit vector of B, is the same thing as saying B divided by the magnitude of B, and we have A dot B over magnitude of B. Same thing. So this will give us right here B, let's put this A dot B all over B squared. Okay, now we recall that what we have under is same thing as this guy here, but this time it's squared. So let me just copy this part, copy that part, and we have it under here. But remember, this time we have it squared, so we are going to have it squared like this. But of course this square will cancel out this square. Okay, so yeah, that will cancel out that. And then for our B and A dot B, note that this B, that B right there, it means x bx plus a y direction, b y, x z direction, z direction, b z, and then we have a dot b. I can also open this a dot b, but I'm just trying to manage space here. Of course, we've opened a dot b in equation 3. So this will give us, let's just move this whole part. Good. So of course we said we've cancelled out this guy, so let's just really take them out. Cancel out that guy. So this will be left right here. Okay. And then for this, we can say this guy, if I open this, it will be really long. So we can say this will multiply what we have here. Let me put this bracket here. Okay, I'll put this bracket here. Yeah, because that's a separate stem. Separate stem with the bracket here. So yeah. So with this we can now say this guy will multiply this will multiply this, and this will multiply this. That means we can have something like this. Let me paste this for the third time. We can have something like this. Copy this part. So I want to write this whole thing again, but I'll just copy it. Make life easy. Good. So what I'm going to do is this. I'll cancel out, but let me just clear off these guys and write this in again, because now we are going to multiplying everything we have in here. Everything we have in here by this guy outside. So the first part will now be an x direction, bx, and then we now have a dot b. Then we now have plus y direction, by, a dot b. Then we have z direction, bz, a dot b. Perfect. Okay, I think I won't stop here. Yes, we can. We can stop here. Okay, so this, of course, this is a general vector. So when dealing with, when we have values for the vectors, the simplification will make more sense. Okay, for now we're just dealing with general form. So yeah, that will be all for this video. Okay, so of course, if you have any question, of course, leave it in the comment section. Like, share, subscribe, comment, and I'll see you in the next video. Thanks a lot for watching, and bye for now.